Today we are going to learn how to use a meter bridge to find the resistance of a wire and thereafter learn how to calculate the specific resistance of the material of the wire. The apparatus that you need for it is a meter bridge. You will need a galvanometer, you will need a key, you will need a screw gauge, a jockey, a suitable ruler, a battery eliminator of course, a rheostat and a resistance box. Connecting wires and a sample resistance wire for which we will find the resistance for a certain length and then calculate its specific resistance by using the diameter of the wire. Now, let us look at the circuit diagram. Let us see the circuit connection. This is our eliminator. From the positive of the eliminator output, the wire goes to the key, from the key to a rheostat to manipulate the value of current in the circuit. It should never be too much. Then this goes to one end of the meter bridge wire, which is marked A. The meter bridge wire is this. Attached to it is a meter scale. As you can see, it starts from 0 here and ends at the 100 mark on the other side, and there is a 100 mark here, which means the 0 for this side of the scale is on the other side of the wire. This is the 1 meter length of wire that you can see, and we go on to its other end, which is the point C. From C, the wire connects to the negative of the battery eliminator. So, this is our basic circuit for the bridge wire. The two other connections which are important are through this rectangular metal strip, one portion of it here, the other here, leads to this gap between these two terminals. We are going to connect our resistance wire by finding a suitable length and place it here. The rest of the terminal goes on to point B. From B we have a connection to the galvanometer. The galvanometer second end is joined to this jockey. The jockey is this flexible point which can be taken anywhere on the wire. It is designed to have an edge on one side. There is a metallic rod between this terminal and this end, so that the connection is there. This portion which we touch or hold the jockey with is made out of ebonite or plastic. So, we do not touch the wire. In the other gap, which is F, you place a resistance box in which you have the option of choosing resistances in step, and this will be our known resistance. So, this entire setup has 4 resistances as required by the Wheatstone bridge. Where are these 4 resistances? Let us first understand that. The moment you put the jockey anywhere on the wire is divided into 2 sections. This part 0 to this length and 100 minus this as the other portion of the wire. So, these are 2 resistances. One, our unknown resistance which is placed in gap E, and our known resistance which is placed in gap F. This will be our 4 resistances connected as required by the Wheatstone bridge, and in this particular way we can use it to find the resistance of this wire. The formula that you will require will be the resistance of the wire, say, is represented by S. This is equal to R, the resistance which you will take out from the resistance box, AD divided by 100 minus AD. AD is the length where you will get a balance length on the wire meter bridge, and 100 minus AD would be calculated from there. The second formula that you will require to use for specific resistance would be coming from resistance equal to rho L upon A. Rho will be then equal to, our resistance is taken as S in this particular expression. So, S which we calculate after doing the experiment. So, S into A upon L, where A is the area of cross section, L is the length of the wire that we select. We will now do the experiment. To start the experiment, we must first take a length, and to note the length of this wire, let us connect one terminal, hold the wire in such a way that it is straight without kinks, and supposing we are using or finding this length to be 20 centimeters. So, we are using 20 centimeters of the wire, make a small kink here or turn it in such a way, connect this kink at this point, tighten it. So, the wire between the terminals, the length of the wire between the terminals is 20 centimeters. Before going ahead, you need to do one more thing, and that is to find the diameter of this wire. You have a screw gauge, you find its least count, note the least count, look for any error in it, zero error in it. Thereafter, use this to find the diameter in at least 3 or 4 different places of the wire. Record it in the table by writing the main scale reading and the circular scale reading. In our case, the circular scale reading is 25. So, the least count of this being 0.01 millimeter, the reading here will be 0.25 millimeters. We first switch on the eliminator, close this main key. So, the current is now flowing in this circuit. Let us check whether our circuit is correct. For this, I take out a 2 ohm. I have arbitrarily selected this value. Looking for deflection by touching the wire at any one end, the deflection for me is on the left side. I take this jockey to any other point on the other side. The deflection this time would be on the right side. That means, in between these two positions, there should be a position where there will be no deflection. Let us take readings now. Take out a suitable resistance, like this. Suitable means you will have to estimate what would be the resistance of this wire. I have taken 1 ohm resistance from the resistance box, and I am using this jockey, sliding it over the wire, watching the galvanometer carefully for the deflection. What we are looking for is zero deflection in the galvanometer. That will be our null point, a point where the Wheatstone bridge is satisfied and the meter bridge would be balanced. Going along here, we find that this value is obtained at 75.3. For the next reading, I pull out 2 ohms and again look for zero deflection. Starting at a position here, looking into my galvanometer carefully. Remember, you should never press the jockey too hard on the wire. It will create kinks and add additional resistance. As we go along, watch carefully. You are getting zero deflection at this point, and reading it off on the scale, from again A is 61.4 it is. So, that is the reading we will note. Now, we make this resistance box with 3 ohms. Again repeat the experiment, looking for a balance length by moving the jockey and watching the galvanometer carefully. So, the reading now is 52 and the deflection in the galvanometer is 0. So, this is my balance length. Make note of that. With 3 ohms in the resistance box, 52 is my balance length. For the next reading, we increase this resistance in the resistance box to 4. Look for the balance length again, repeating our experiment, looking for 0 deflection in the galvanometer. This value is 44.9. We can take one more reading, select 5 ohms, 2, 2 and 1 from the resistance box and looking for a balance length. Once again, carefully, without pressing the jockey too hard, sliding it gently over it, watching our galvanometer. This is a value of null point and consequently our balance length is now 39. These readings should be taken very carefully, because the care you put in this is going to determine how accurate your calculations will give you as a result the resistance of this wire. Let us use the readings we have just taken and calculate the value for resistance. Our observation table looks like this. We will first calculate the value of 100 minus AD. So, the first reading with 1 ohm is 24.7, the second one with 2 ohms is 38.6, with 3 ohms 48, 4 55.1 and with 5 ohms it is 61.0. How do we calculate? Our formula is S is equal to R, the resistance box value, AD upon 100 minus AD. Substituting the value, say for the reading of 2 ohms, R will be 2, our AD value for it is 61.4, this divided by 38.6 and we can see that it comes out to be. Likewise, find the value for the resistance in all the other cases, average out for the 5 that you have selected, or if you chose to do 10, then average that value out and get the value for resistance of the wire. The next thing is to be calculated is your specific resistance of the material of the wire, the formula for which, as we have just written, rho is equal to S into A times L. Here A is to be calculated using pi r square, but we have taken the diameter and therefore, what we need to do is diameter divided by 2 square, this would be our value for area of cross section and length. Remember, you must keep all the units the same. This of course is in ohms, which we have just calculated. The other value of area should be converted into meter square. The value for L should be converted into meter. So, whatever you have taken in centimeter or millimeter in the lab should be first converted and then the calculations done. Substitute and find the value with the mean or average value for the resistance that you have obtained during the experiment. One other way of accounting or taking care of this extra resistance which we do not know or we do not take care of is that you interchange the positions of the wire and the resistance box in these two gaps E and F. That means, instead of putting the resistance wire in E, you place your resistance box here, and this particular resistance wire goes in this gap F. All that will happen is that you will have a set of readings, and when you calculate the value for resistance again, you will have to make sure that you account for the ratio that you had selected in your Wheatstone bridge expression, so as to change it or convert it for the meter bridge expression, and therefore, the formula will just slightly change. Other than that, the value of the resistance is not going to, and you will get a set of 10 values for the resistance. Averaging it out, you will get an accurate value of the resistance of this wire. What you can go wrong in, you need to understand. Some of the things that you may forget, that all connections should be tight, the reading should be chosen to be around the center of the wire, not too close to any one of the ends A or C. Then for extraneous resistances, interchange what you have placed in gaps E and F. If you did that carefully and not putting too much current in the circuit, you will get very good results by using this very sensitive and easy to use apparatus. You can use this apparatus for doing many projects. So, you have seen that you can use the meter bridge to very accurately find the value of resistance of a wire. Can we use this apparatus for other useful purposes? Some simple projects that you can do can be that you can find whether a wire is homogeneous or not by taking different values of length, determining the resistance for it, and if it comes out to be uniform, then the wire is of uniform cross section as well as uniform homogeneity. You can do some other experiment also. The resistance of a wire changes with temperature. How can you change the temperature of a wire like this? You can dip this in a bath of mustard oil, take a temperature thermometer for 0 to 300 degrees Celsius, use a burner, gradually warm and heat this wire, take the change in its resistance, that means take the resistance at different temperatures. You can plot a graph or you can even calculate those values and do a nice experiment with it. You can find the resistance of a bulb, take a bulb, take a crocodile clip, put the two ends in one of the gaps, either E or F, determine its resistance, and you can have some more experiments that you can design with it yourself. So, application of meter bridge is tremendous. It is a very useful device. It will always give you very accurate values for resistance, and you can always rely on it.